start, and I'll try to keep the session a bit interactive, wherein I might ask some questions in between in terms of where you're putting attention or not, and you can answer if you're able to understand and focusing on the concept. So I'll start sharing my screen, and if you are able to see my screen when I start sharing, please give me a thumbs up.
Before that, Pawan, I will have some introduction of what we are done as a
Okay.
cloud AWS Cloud Builder series. So I
Yeah.
am welcoming each and everyone who has joined today for this session, and so. This is our third session in the AWS Cloud Builders series. As Pawan mentioned today, it is going to cover about the networking fundamentals. So it will be it is basically a strong foundation of networking fundamentals, and stay active throughout the session as Pawan mentioned. So we are having a quiz today, and the quiz winners will have some interesting prizes, I can say. And also I have an announcement at the last of AWS Community Day Chennai, so that you will get an exclusive offer if you are in Chennai or any other parts of the India. Like if you like love to attend the ACD Chennai 2026, which is happening at March 7th. So I have an exclusive offer for you, those who are attending the session. And before that, so I want to introduce myself. I'm Abhinaya, and I'm an AWS community builder, and also I'm organizing this AWS Cloud Builder series online. And as I mentioned, this is our third session, and yet to have I think one or two more sessions in this series. And also, I was happy to see many of familiar faces today, like Bhumi Raut, Rasika, Angisha. Everyone is attending regularly, and yeah. And handing over to Pawan.
Yeah, thanks so much, Abby. Thank you, Raska, for joining. You will be, I mean, your help will be required for helping Abby and myself. Okay, so with that, let me start sharing my screen. Are you able to see my screen?
It is loading, Pawan. Yeah, I can see.
I don't know why it is showing like this. How to minimize this? Sorry,
You can cancel it, I think.
is it?
It is visible, Pawan. Yeah, it is now good. You
Okay.
can put the hide one, stop sharing. After
Yeah.
that, there is a hide, right? Yeah.
Okay. Thank you so much. So, how do you define network, computer network? Any of you want to answer? Unmute yourself and want to answer simple question. What is computer network?
It plays the role when the communication happens between two devices. In the case of operating system, when in a single device, when many processes we manage, that is handled by operating system, and whenever the communication happens between from one device to the another, it is handled by the network.
Yeah. Thank you. Sorry, I did not see your name because I'm sharing my screen. So, what's your name?
Aman.
Okay, thank you, Hemant. So, a computer network is a network when there are two or more computers connected. It is locally or remotely, right? So we talk about local area network, WAN, wide area network, and all that, right? So if two or more devices, and here we are talking about computer devices, if they are connected, that's what makes network of computers. Okay. Now, first topic I'm going to cover is client server model, then TCP IP model slash OSI model, and then I'll go and talk about subnet, subnet mask, and block size. What is how subnetting is done, how block size helps in subnetting. All these topics will be covered today. That's the agenda. Let's see how much I can cover. Client server model, again, very simple, and most of us are aware, right? Because it's a fundamental. I'm touching upon all these concepts just for refreshment for each one of us. So once I'm sitting on computer, right? And you are, or we all of us are able to, sorry, connect to this channel which is on the Google, right? So Gmeet, and through that you are able to see this screen right now, right? For example, if I am connecting, what I did was, like, let's say, take the another example, right? Most of us are using Google for search and all that. So when I search on google.com, right, and put any URL on that, right, so what I'm doing is I am opening the browser, and then whatever URL I'm typing, right, I in the first session of Cloud Builder series, I talked about DNS mapping and all that, how it converts or it translates the domain name into IP addresses and all that. So I'm not going into that detail right now, but what I'm trying to say here is, let's say I'm trying to hit a URL. What happens is the respective server, right, which is translated by the DNS in terms of IP address, it finds that server, and then corresponding resource which I'm looking for, right, that is being responded by the server. So it could be uh, some sort of file based transfer. I'm looking for some file. At the back end, there will be API call. It could be very simple and it could be very complex. But regardless of that, in this scenario where I'm sitting on a computer and opening this browser is the actual client for this server. And the server is responding the respective resource which a client, in this case, uh, I am a user and I am using the client, which is a browser, and server is responding to my request. So this is a very, very simple, I would say, example of client server model. There could be a more complex client server model where uh, a server could also act as a client for another server, right? So it could become like, let's say you're having a server hosted on cloud, right? And you connected to that server through some client, right? And Putty, for example, right? You connected through Putty. Now, you know, most of you know Putty. Putty is one of the clients using which you can do the SSH, and using other connectivity options, you can connect to servers sitting on maybe on-premise or even in cloud. So let's say I connected to my server, which is a virtual machine hosted on cloud, let's say AWS cloud, for example, and I want to set up my Jenkins, right? I want to set up Jenkins on my virtual machine. So what is I'm doing? I'm doing three-step process. First, I'm sitting on my computer here, right? I'm sitting on my computer. In my computer, I have installed Putty. So I have opened the Putty, and then I am connecting to another server, which is hosted on AWS, right? Now on that server, I'm installing Jenkins. I am doing some patch upgrade for database. I'm doing anything, for example, which is hitting that specific server on Jenkins, or maybe I'm upgrading, or I'm installing some patch for my database, MySQL version. So, so in that case, let's say I'm setting up a patch, or I'm setting up Jenkins, right? So, in that case, whatever patch is available, for example, on that particular MySQL server, so it is behaving. So that particular VM which I'm accessing, that becomes the client for that server, which is responding to me with the my SQL my SQL patch, which becomes the resource for me, right? So that is a relatively complicated example, but in that scenario, the virtual machine which I'm accessing becomes the client for that server, which is remotely sitting, right? So This is the client server model, and I hope you understand with this simple as well as the complex but a practical example which we do on daily basis right nowadays. So you are not just working on your computer, you are accessing many of the remote resources, right, from one server to other. So this they are all examples of client server model. If any of you have any questions, you can put in the chat, and towards the end of the session I'll try to answer as much as time allows us. Okay. OSI layer. Now, this is layer. I'm sure if you have understood or you have gone through networking course anywhere, then you have come across these layers. This is not something which is I'm doing for the first time, but again, as I mentioned, it's important for the fundamental perspective. So OSI layer, it's having 7 layers starting from top to bottom. If I talk about physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. However, nowadays, what is happening is people are moving. So this layer is still used from reference perspective. However, from pragmatic use perspective, people have moved, or not, I would say moved completely. However, people are using TCP IP layer more compared to OSI layer. And how that looks, it looks like this TCP IP model. So the what is different? So the two layers, presentation layer and session layer, is not there in this. Everything else is same. So they have combined application layer, presentation layer, and session layer, all these three uh, within application layer itself, and then the remaining 4 layers at the bottom remains as it is. Primarily, I would say they are segregating in a way the software related layer to relatively network and other hardware related layer, which is physical layer, and data link layer, which is physical layer is proper hardware related layer, or it's the name suggests it's a physical. Data link layer is, of course, it's not completely physical, but it works very it works in conjunction with physical layer. So these 5 layers are TCP, called TCP IP model. The top to bottom is where encapsulation happens, and the bottom to top is the decapsulation happens, right? So let me let me explain that what exactly happens in each of these layers. Okay. Now, so when the data is being transformed from application layer to transport layer to network layer to data link layer and eventually to physical layer, it it is called PDU, protocol data unit, even though the format of data in each stage at each layer is different, right? So I try to put all these important details here which will help you to understand. So let's say I'm trying to access a service, okay, in my browser. So what I'm doing is I'm working on application layer right now. I have opened a browser and trying to make a call, which at the back end, of course, is an API call, but at the front end, it is probably FTP call or any other call which is dealt with at application layer, but at the back end, that translates in form of 0 and 1, right? So as we all know, computer deals with 0 and 1, right? So the data is in moving downwards means into the other layer, uh, so-called transport layer in this picture from TCP IP model perspective. And they so now application layer is done. What it did, it deals with some service which is uh, I'm sure you would have heard of port, right? So how transport layer works and how it identifies, uh, or any other layer, if network layer has to connect with the transport layer and try to identify where the service X or service Y, let's say FTP is running on port 21, and let's say HTTP request which is running on port 80, right? So how transport layer will segregate, it is with the help of these port numbers. Transport layer will be able to uh, I mean, other layers, sorry, other layers which are interacting with transport layer, they will be able to segregate these services. I'm just, this is a random service one and service two I've given. Okay. It could be other ports, and the port number also I've given random, though it might be the correct one. And the name I'm giving for the service, which is specific to protocol HTTP, and one is FTP, for example. But it could be, this is what we need to understand is the port number. It's not the actual port we are talking about, it's the port which is assigned to that particular service. It could be XYZ port also. Okay. Probably because 21 and port 80 is something very common, we all know, that's why I put this. So coming back, so what happens at transport layer is the conversion of data from bits to segment is what happens at transport layer. Okay. Now whether the application layer is interacting downwards with the transport layer, or network layer is interacting with transport layer upward, right? Regardless of that, it is able to identify that service with the segregation of through port itself. That's why port number becomes very, very important. Okay. Because what happens is, let's say uh, you are trying to fetch some, let's say I'm trying to connect with the uh, S3 bucket, AWS S3 bucket, right? Which is object storage. Now, S3 bucket can contain any type of file. It can contain JPG, it can contain exe file, and of course, we do not store exe file in real example. However, it can still contain, right? So example, what I'm giving here is, and the context with which I'm talking here is how uh, that particular layer where it is trying to deal with that particular file, it is trying to understand what I have to do with this file type, how it segregates. If it is exe type, probably that's when it understands, okay, I need to execute it. But if it is let's say JPG file or PNG type, right? So it understands, okay, I have to render it in front of the user probably, right? So that's the difference, which through you with the help of file type or MIME type, right? It's able to segregate what action has to be taken by the respective layer. In this case, let's say application layer, eventually when the data comes back to the application layer, that's how it renders. Or if it is exe file, it has to execute that. So those uh, decisions it takes on the basis of, let's say, file type. Okay, it's just one type of example. There could be different examples in the real time. But yeah, again, just try to understand what I'm trying to say here, how these layers work together with each other. So after transport layer, the segment. So now segment has one more advantage, why it actually converts that into segment. Segment means the one byte or one, so there's a number of bit and byte here. So this example I have given. So the data is in form of zero and ones, right? Now it does not create a single pack, right? It segments the data. Why it segments? There are multiple regions for better performance. There's something called multiplexing and all that. In that scenario, multiple operations are happening in parallel also. That's why it helps to improve the performance from security perspective also. It helps. So segmentation is that's why segmentation is done, right? So the data is not in one pack, you can see. It happens that it segments that data in multiple different parts, which is called segment. Okay. Now the AP, so the protocol which is taking care of this, probably transport layer, I can say, or we can say it's one of the most important layer for all of us, because TCP, I mean, let's keep UDP aside for now. So let's focus on TCP only. So the TCP is the protocol which is having one of the, I would say, it provides better reliability, right? That the data which I have transmitted from source, right? It will get, so it will be nine out, I mean, 10 out of 10 times, there's a guarantee that it will be delivered, right? So that's what the TCP is, like you can say that it is, I'm not saying it is very slow, but their priority is not time. Their priority is reliability, right? If data has moved from source, then it has to be delivered on destination, and also it provides acknowledgement, right? So that's what TCP is. Again, I'm not going to go into a lot of detail about TCP protocol, but at transport layer, it is TCP which takes care of handling this segment. Okay, now it moves to next layer called network layer, and it converts that segment into form of packet. Okay, and the protocol it deals with, the protocol which does it is IP, internet protocol. IP stands for internet protocol, and the format the data is at this stage is in packet. Now, as we all know, the IP is having source address as well as destination address. The data has to move from router 1 to router 2. uh, I mean, router 1 and router 2 are actually the, you can say not middleman, but yeah, it connects more than one network. That's why you need router, right? So if the data has to move from one network to other, that's why you need router. So what I'm trying to say here is it needs the source address. It also needs the destination address. That's why the network layer. That's what the network layer does. Again, these two, transport layer and network layer. If you see, one layer is being handled by the protocol called TCP. The other layer, which is the network layer, is handled by the protocol IP. Right. That's why this model is also named as TCP IP model. Okay. Now, the next layer, the downward layer, is where uh, it is called, I mean, the data which is so far is was in the form of packet. Now it gets a frame. So on top of packet, it creates a frame and it put into it, and it transmits that data. How it transmit and which protocol? There is a protocol called Ethernet, which happens at the data link layer. Okay. Now, at this stage or at this layer, the also the source and destination address is there, which is called MAC address. Now, this is a physical address, right? If you do your if you open your laptop, for example, and if your Windows laptop, then if you do ipconfig/all, right, it will give you all those details. What is the MAC address of your device, right? And a lot of other details it will provide. Um, I'll show you. I'll not show you the ipconfig/all, but at least I'll show you ipconfig in terms of the IP address and other aspect which I want to talk about in the next few slides. So this is the layer at which the MAC address is what I mean. Data link layer is what is being dealt by protocol called Ethernet, and it has a physical address which is something you cannot change. The IP address which you have, let's say I am doing IP config today in my computer, it is giving a IP 192.168.2.0, for example, right? Tomorrow or maybe a month down the line, right? It might change. But the MAC address of my laptop or your computer will never change. It is something which is done once and it's done. It's done and dusted. You cannot change it. Now, the next layer is the last layer, which is physical layer. There, the data goes back, and then it too takes that data, which has come all the way from application layer to all these layers to physical layer, and sends it to the the actual destination in this case, right? Through router and other devices, right? In the form of signals, right? That's why it is called physical layer. Okay. So with that, I'm done with this particular slide, which is probably one of the most important one. Again, this is something for you. I mean, from understanding perspective, it's important for each one of us to know it. However, the session I'm going to talk on VPC, probably you don't need to you don't need to remember it much. But in the real time, when you talk, let's say you have heard of WAF, right? AWS WAF, Web Application Firewall, right? Now, WAF works at layer 7, right? They call it layer 7 because WAF works at application layer. So in OSI layer, it becomes a layer 7. But if I talk about TCP IP model, then it becomes layer 5. But generally, for reference perspective, generally they talk about layer 7 from OSI reference perspective. So my point here is, if somebody is talking about these layers in a certain certain discussion, whether it's a network team and other team, for example, you should be able to understand what they're referring to. That's why knowing these layers from reference perspective is important. However, you need to understand this particular TCP IP model better, because you will not get much chance where you're talking about presentation layer and session layer. Primarily, you're going to talk about these five layers only. Okay. So with that, let me move to a very important topic, IP4 basics. Now, IPv4 basics. So we all know there are two types of IPs nowadays, right? I'm not nowadays. It's since for last few years, even IPv6 is there in picture. And now, if you do the IP config in your laptop, you mostly get IPv6 address also listed in that IPv config command output. So, of course, I'm not going to that direction why IPv6 and significance of that, but rather I'm focusing on IPv4 today. So, what it has is it contains four numbers, and each of these numbers are in the range of 0 to 255 inclusive. Okay. Now, if there is an IP address, so I'll talk about it. That if you see, this is the IP address here at the bottom. So 192.168.10.15. So let's say here I get 192.168.260.15. Is that a correct IP address? The answer is no. None of these numbers can go beyond 255. That's the limit. Okay. Similarly, none of these numbers can go in negative. There cannot be an IP address which has a negative value for any of these bits. Okay. So these four numbers are divided by dots named as dotted decimal. Okay. Though IP address is the host address, with the help of subnet mask, it also tells the exact network address and the exact host address. So this today's topics probably one of the most important aspect for you to understand is what is subnet mask and what is its significance and how it is going to help us. Now, if you look at this IP address 192.168.110.15, okay, now this is IP address of my laptop. But looking at just this address, I do not know my laptop is part of which network address. Do I know it? No, it does not give that indication. It is just telling this is your IP address, this is your identity, means my computer's identity currently. So subnet mask is that particular parameter or value using which we can identify both what part of that this particular IP address belongs to network address and which part of this IP address belongs to host address, means my laptop's address. And this is one of the most important topic I want to touch upon. I hope that by the end of today's session, you will be able to confidently understand these things. Okay. So that's the agenda of today's session. So, and that's why I brought this question, IPv4 practice questions. Just one question. Are these two IP addresses 10.15.1.8.108.200 and 10.15.106.100 on the same network? Any guess? You can unmute yourself and tell me what you think, if any of you want to take this question.
I think no.
Okay, how you know that these two are not on same network? Okay, that's the point. So as I mentioned here in this, right? Though IP address is the host address, with the help of subnet mask, it also tells the exact network address and the exact host address. So try to understand one thing. IP address, and when we talk about how differentiate it's which part of it is a network address and which part of it is host address. A very common and very practical analogy we have is about the street name and the house name. So I'm staying on a street called Campton Drive, and I have given a house number where I stay in UK. Now, which part of that particular, because there are multiple houses on the same street, right? So which part designates only the in this particular IP address designates or it corresponds to only the street name, and which part is the only the host name. So that will be only that is something we can tell only if we are aware of subnet mask. Okay, I'll talk about what is subnet mask. So this session is about, you can say that probably 50% is about subnet mask. If you understand that, then you understand this concept. Okay, before we move to that, this is something I put in the last minute. I think there are some issues due to which I could not do it in proper way, but this is not bad. I'm sure many of you know, and this becomes important for you because we are going to deal with these two versions of the numbers, right? So that's why I put this binary to decimal and reverse process, which is decimal to binary. So if these two numbers, right? Okay, this number 1001, right? So 1001 is a binary number. Now, if I have to convert this number in form of decimal, right? Uh, how we do it? So, uh, I mean, I can go deep in it, but I do not want to go in deep. If you have any questions, even you can ping me parallelly. Sorry, later on I can explain to you. But I'll try to explain. This is something we can remember, but there's a logic behind it. Okay, it's not just I'm telling you to mug up, but uh, we are when we talk about this IP address, right? So this when you talk about this IP address, this is each of these value, right? Each of these numbers at the back end is result of a binary value, which is in form of octet. So octet stands for 8 bits. Okay, so there are 8 bits in once you sum the value of those 8 bits. That's why each of these numbers come into. So this 192 is the value of sum of the value of 8 bits, which is in the binary format. Once you convert those 8 bits in the form of decimal format, that's why you get the number 192. Then again you get another 8 bits, which is the result of the combination of those 8 bits value in the form of decimal number. Then you get one. If you sum all of those, then it becomes 168. Then there's another bit which is and again binary, and then you convert each of those in decimal, and then you get 10, and so on and so forth. So it is actually the 34 bits, 8 8 8 8 8. So there are 8 into 4 bits, which are 32 bits, using which separately for each 8 bits you convert those numbers in form of decimal, and that's why we get this number, which is IP address. Okay, so that we need to understand. So here I have tried to explain that. So this is 1001, which I have to represent in form of 8 bits. Then what I'll do is 1001, but at the left it will all zero because there's nothing. We have to complete the 8 bits. So then how will I complete? I have to add zero for each of these remaining bits. So then 8 bits got completed. Now, for number one, so the positional value of this is always going to be 1. Okay. Now, I'm talking about this value, which is this is the positional value 1, 2, 4, 8, 16, 32, 64, 128 is the positional value. I'm not talking about the value of this number. Now, that will come to know what is the value of this particular number at the moment, but this is the positional value which is fixed. Okay. Now, depending upon, because we know that binary can have only two type of values, it will be either 0 or 1. So if you multiply 0 by 2 or any number, it will always be 0, right? So any number which is multiplied by 0, regardless of its position, will be always 0. So these two numbers give me only 0. That means I need to calculate what is the value of this particular one and what is the value of this particular one. So for that, because the positional value of this number is 1, so I have to multiply 1, which is the actual bit is here, right? So 1 I have to multiply with 1, that becomes 1. And 1 I have to multiply with 8 because that's the positional value, it becomes 8. So 8 plus 1, this is something representing 9. Okay, now how about converting decimal to binary? Now what I have done is, so in very when I was I was literally a kid, like probably in my school days, right? So that time I used to use this formula. I mean, as I mentioned, there is a lack of time. There is other way to, or maybe more efficient way to do it, but that is something I'll talk about. Not especially for binary to decimal conversion, but as part of explaining some other concept, I'll explain that method also. But at the moment, just try to understand this. So how I used to do in my childhood was this. Uh, there's a number called 12, for example, right? Now I have to convert this 12 number, which is a decimal number, in form of binary. How will I do it? I will divide, because 2 is the base, right? Binary is the, in case of binary, it's a base 2, right? So I have to divide with a base, which is 2 here. And I keep putting the sorry, I keep putting the reminder here, sorry, remainder here, 0. So if you divide 12 by 2, that becomes, it is completely divisible, right? So 6 is something which is dividend, and then the remainder will come here at 0, right? Because there's no, it's completely divisible. Similarly, the 6 I have to divide now by 2 again, that becomes 3, it's completely divisible. Then the 0 becomes the remainder here, comes here. Then I have to divide 3 again by 2, then it becomes 1, right? Because it's not completely divisible. The remainder is 1, and here the next dividend also is 1. The final dividend becomes the part of the actual binary number, and I take from this way, from left to right, and this whole thing becomes the actual value of 12. So 1100. And if I do the reverse of it, right, which I explained you, right, if I have to convert this number from binary to decimal, this is how I'll do it. Just if I'm following this method, then this is how I'll do it. So 1, 2, 4, 8, 16, 32, 64, 128. So what I'll do is, this is the value I have, 1100. Here the positional value I have put at the top, don't worry about it. And the actual value, which is 1100, I have put at the bottom. So what I'll do, I'll multiply. 1 with 0 is 0, 2 with 0 is 0, 4 with 1 is 1, and 8 with 1 is 8, right? Sorry, 4 with 1 is 4. And I'll sum these four numbers. So 8 plus 4 plus 0 plus 0 becomes 12. That's also confirmation that this is the correct answer, right? So again, this is not very efficient method, but for this purpose, for conversion from binary to decimal, this is definitely efficient method. But from decimal to binary, there is a more easy method, which I'll not explain that particular concept itself, but as part of explaining something else, I'll touch upon that. Okay, hope you understand. It's again the revision class, because all of us have gone through this conversion in our childhood as well as in college days. So now the main topic, subnet mask. Okay, so just keep yourself attentive here, because this is a topic which I wanted to understand really well. Okay, now what subnet mask is? Similar to IP address, subnet mask also contains four numbers. Okay, similar. It's not identical, but the concept is different. But it always look like there is another IP address itself. The way subnet mask is being. So it also contains four number, and each of these numbers are in the range of 0 to 255 inclusive. Okay. The four numbers are divided by dots named as dotted decimal, as I talked about earlier. The dividing line is when 255 stops. This is very, very, very important. The dividing line. Okay. Dividing line is when 255 stops. Okay, what it means and why, what is the significance and relevance of this particular concept, you'll come to know. Now, subnet mask in its binary representation is always contiguous one on. Means, so because it's a binary number and you have only 0 and 1, so 1 we are calling it on. It's like a switch, right? Switch is either on or off, right? So if it is 1, then it's on. If it is 0, then it's off. Once it stops, which means it is all off after that, and only zeros after that, like 000 and all, and so on. So what it means is, once you see 255, 255, 255, right? So it cannot happen in case of subnet mask that after 4 1 you get 10, and again you get 1, and again 20. It will never happen like that. The moment 1 is not there, it will always be 0. So it starts from left to right. if you see the example, right? So 255.255.255.0, or it will be like 255.255.0. It will never happen that it is like 255.0 and then 255 again. It will never happen in subnet mask. Okay, that's one thing you need to remember. Now, looking at this address, right? Now, this is the address. You need to tell me what is the network address of this IP address and what is the host address of this IP address. Now, you have to tell that on the basis of subnet mask. Okay, probably I have not explained the concept as much. Let me first explain. So, I was telling that this concept. I asked this question, remember this question also for reference. We'll come back to this question also. So here I was telling that though the IP address is the host address, with the help of subnet mask, it also tells the exact network address and the exact host address. Now, so on the basis of subnet mask, how it tells that? What is the dividing line? So there has to be some delineation, right? There has to be some separation where it tells, okay, this is the line where it is the network address and this side is the host address. Now, this is being decided based on the value of subnet mask. If subnet mask is 255.255.255.0, that means this network, this particular host has 192.168.1 as a network address, and dot one, only this part, dot 88, is the only host part. That you need to understand. However, if the subnet mask becomes 255.255, then this becomes, the network address becomes 192.168 and the host address becomes dot 1.88. So that's the difference. Now, if I have to now know that these two address 10.15.108.200 and 10.15.106.100 both are on the same network or not, for that, let's say the subnet mask value is 255.0.0.0. Okay, for both the IP. Now, my question is, are these two IP addresses on the same network or not? If you have not listened, let me repeat. IP address is in front of you. Now, subnet mask is 255.0.0.0. There are three zeros and only one 255. Okay. Now you can say you have to answer these two networks are the same. So these two IP addresses are on the same network or different network. Anybody? Did you understand the question? Hello?
It will be same network.
Hmm. Thank you. Anybody else? I think number of them have answered. Surveys is saying no. Dinesh Raj is saying same network. Satya is saying same network. Okay, good. So it it is on the same network because the subnet mask I told you is 255.0.0.0. Because the subnet mask is here. This is the dividing line. Because it's a 10 network, both becomes 10 network, same net. If you see the 10, that's why it's a 10 network. We can say this particular, if subnet mask is 255.0.0.0, that means this is the dividing line, then I can say both the devices or both the IP addresses, of course, it's part of some device, right? I mean, this IP address is assigned to some device, right? That means both the computer which are having these IP addresses on the same network. And then what is the name of that network? It is called 10 network. And what is the host address? That becomes dot 15, dot 108, dot 200, and dot 15, dot 106, dot 100. The host address will always be different because those are two different devices, but then they are part of same network called TAN network. Now, next question or next example. I mean, same example, but another subnet mask. The first subnet mask I had given you was 255.0.0.0. Now the second, let's say the subnet mask value changed. Now it is 255.255.0.0. So the 255 and after that the two zeros. That means it comes here after 15, 10.15. Now you tell me both both these IP addresses are still on same network or they're on different network. Yeah, you can put in the chat also. That's fine. Now I'm repeating again. The people who have not answered the first time, you tried next this time. The subnet mask is 255.255.0.0, and now on that basis, here the dividing line comes here after 10.15 because to 255.255 here it comes. Now you have to answer these two devices are the part of same network or on a different network.
It will be on the same
I'm just
only. So
Oh,
it will
we are
be on the same.
getting some new people are answering. That's a good improvement. Thank you so much. Yeah, they are still on SAM network. Okay, let me ask next question. Next scenario, not next question. Next scenario. Okay. Now, now the subnet mask becomes 255.255.255.0. Listen again. Now the IP address is same. These two only. Now, the subnet mask becomes 255.255.255.0.
It's
Now you have to tell me,
different.
yes, it's different on different network because now it becomes standard 15.1.8 network and it comes on a different network called 10.15.106 network. And then this host address becomes dot 200 and this host address becomes dot 100. I hope I hope now you understand. Some of you have understood, or most of you have understood, right? If you were already, yeah, thank you, Aman, thank you, Angi, yeah. So thank you so much. I think most of you have answered. Even if you have understood this concept earlier, I'm sure it's a good revision. Those of you have not understood this concept, this is something I hope it is helping you to understand. Okay, uh, I'm still sharing my screen, right?
Yeah, it's sharing only. Yeah.
Okay, now I'm making it bigger screen. Fine. So this is a very important concept. Sorry, I'll just take a 1 minute break, Abby. I'll be just back. Just a minute, okay?
Yeah, thank you for joining, everyone. I see some new members also joined after in 10 to 15 minutes. Yeah, hi, Sarvesh. I think I saw you in one of the event, I guess, right? Is that a student community day, Sarvesh? You can unmute and introduce yourself. And I saw a few members also, like Dinesh. So meanwhile, we are having a quiz that lasts like 5 to 10 minutes, so that so that you guys can attend and win some prizes. So I want to make one announcement. So there is an event upcoming, that is AWS Community Day Chennai, which will be happening on March 7th. So I will post that link. If you are interested to attend, you can register and come on that day. Like there will be three tracks happening, and also yeah, and also there is an workshop also going to happen on that day. I'm pinging the link in the chat. So the tracks are yet to publish, Dinesh. So it will be one of Chennai and one the other things will be the serverless and
I'm back.
yeah.
Okay. So we are still having 25 minutes, so I think I should be able to cover whatever I have planned. So let me know if you're able to see my screen still. Hello, you're able to see my screen?
Yes, Pavan, it is visible. It is in the same screen only. Subnet mask.
Okay. Is my voice sufficient enough, right? I think I'm talking. Sorry, now it should be better in terms of my. Um, you can hear me clearly, right?
Yes, Pawan.
Yes.
Okay. So yeah, I think you understood. So in this case also, if you what I'm trying to say here is 192.168.1.88. So let me quickly show. I mean, because I'll not get much time. I have to cover. Probably the session might go 5 minutes extra. I should be able to cover everything otherwise. So let me show you this. So I'm just putting IP config. Okay. This is a Windows laptop I have. So this is my IPv4 address. Now let me do this full screen. This is my IPv4 address. This is subnet mask, right? So can you tell me what is the dividing line for this IPv4 address? 192.168.188, where the network address ends and where the host address starts. Can you tell me? You're trying to put in the chat.
Sorry, I missed it, Pavan. What's the question?
So my IPv4 address of my laptop is 192.168.1.88 and the subnet
Okay.
mask is 255.255.255.0. So where is the dividing line in this? Where this network address is over and the host address starts in this address.
88 is the host, and the first three are the.
That's correct. And if you see here, default gateway, again, I do not want to take much time, but it's important for us to know. So this is the IP address of default gateway. And if you see, uh, it's 192.168.1 because this is the subnet mask 255.255.255. That means here the dividing line. That means these two, 192.168.1.88, 192.168.1.1 on the same network because it's directly connected. This device is directly connected because this is something. I mean, it's my device. I'm connected with my home network. That's why it will always happen that unless you do some sort of adventure, right? You then it that scenario is something I'm not going to talk about. But it's a direct connectivity I have with my uh, Wi-Fi right now. Of course, I'm connected with, but regardless of that, even if it connected through LAN, it will happen. It will give the same result. Now, one thing I wanted to talk, which I could not put in form of slide because of lack of time. is about talking about a bit of router and switches and all that. So quickly I'll say you that router is like most of you, like if you have set up proper network in your house. I'm not talking about the dongle and all, then you would be using router at home, right? You'll also probably you'll be using modem nowadays. I think those capabilities are all embedded in router itself. Like modem does the a bit of tweening and all, oh yeah, tweening and all that, which we call it. But mostly it's a router which has multiple different capabilities, right? It does the address translation, like network address translation. What it means is, once, so if you see this, my laptop IP address is different than this IP address, right? So what happens is the request when it goes to router, when I do google.com, the request which hits the browser, right? The moment it goes, it has to go through router, and the router then forwards that request into google.com, and it hits Google server, right? Now google.com is being, actual request has gone from my computer, but the request which is received by Google, right, or Google server, they are receiving the request from this address, not from this address. That that which means that it enhances the security, because this device work as a, it's part of my private network, right, within my house. And the external system, which is Google in this case, does not know the request is coming from which device, because router is, it works as a proxy, right? It does the translation of this IP address into this IP address, and then the request is received by the third party server as if the request is originated from this address, whereas has been originated from here. So that's the benefit of routing, a small benefit. It also works as, of course, the DHCP server, the router, which DHCP servers is the one which assigns the IP addresses to your devices within your network, right? So in your office network or house network, wherever it is. So I mean, quickly, that's what I wanted to touch. Switch is something is important, but yeah, I mean, I'm not going to cover that. But the router is something which is more important for us to know. So coming back to the slide now, okay. So let's go to the next slide. So this is done. Now, block size, a very important topic from subnetting perspective, both the subnet mask, understanding that, and the block size. Okay. Now, block size, it is the positional value of least significant bit in the subnet mask is the block size, and the least significant bit is the last bit. So just try to digest this. What is the meaning of this? And the least significant bit is the last bit which is on in the mask or subnet mask. So the positional value of least significant bit. So first I have to understand what is the least significant bit. So this part, least significant bit is the last bit which is on in the mask or subnet mask. So this is, let's say, these two are the IP address and the respective subnet mask. One is in the form of decimal and one is something, this is called CIDR, classless inter-domain routing. Nowadays, right, once you do start creating subnet in, let's say, in AWS, while you are trying to create VPC, you have to create subnet, and you have to give this symbol in form of slash XYZ, right? So it's the same thing, but it's a different notation. CIDR stands for classless inter-domain routing. There's a reason for it is it is going to be called as, or it is getting called as classless. Again, I'm not going into that detail, but yeah, there's a different notation altogether, which is based on bits counting and all. That's more easy, I would say. It's not difficult. I'll explain you. So now how we will calculate that, and how I will know that for a given IP address with respective subnet mask, how I will know what is the value of least significant bit, what is the least significant bit first, and what is the value of it. So we'll try to understand these concepts. So this is the IP address, and this is the subnet mask, and this is the IP address, this is subnet mask. Now, subnet mask of first IP address and block size calculation, this one we are trying to do. Okay. So for in this case, the IP address is same in both the cases, but the subnet mask is different. So let's try to analyze it. Now we have to, so the this calculation or this finding is of a least significant bit has to be done in the subnet mask, which is 255.255.224.0. Okay, so this is the subnet mask. Now I have represented this 255. If you calculate, you will come to know. I have given you the number, right? 1, 2, 4, 8, 16, 32, 64, 128. 128 is the last in 8-bit, right? So the positional value, right? If you sum all of that, that's what you will get 255. Okay. So these two are all complete. The next one is 224, which is of course not the complete. That means there would be somewhere the zero will start. Where the zero will start is we have to calculate. So I put this foundation, right? The reference 1 to 4 up to 128. Now, as we remember, right, from the previous uh, slides, that the subnet mask is contiguous 1 1 1 1 1 until it stops, and when it stops, it's always zero afterwards. There's never going to be one after the zero again. That's how it is. So on that basis, so we'll how we'll do is, again, as I told you, right, how you convert the decimal to binary, right? So in this case, what I am doing is I have to convert this 224 in form of binary so that I know where the zero starts, right? So I'll divide it, not divide, I would say, but I'll try to see whether 128, which is the maximum number I can get in this 8 bits, right? I have to start from this side, as I told you that it will start like this, 1 1 1 1, and then it will go towards zero. So I will put 128 in, and in 224, will it fit? Yes, it will fit. That means it will always be 1, right? The remainder will be something, right? That something could be that, and we have to calculate, right? So if you are good in maths, right, you can do it. But I know the 64 will be fitting in the remainder also. So I put 1. This 32 will fit in out. Again, I have to calculate how much is the remainder after I have deducted 224 with 128, and then I deducted that remainder with 64. Uh, Again, I'm not doing the calculation. You have this slide tomorrow or today, right? You can do the calculation and see this. So the last one is something I have to see whether 32 fits into that. The coincidence is 32 is completely fitting into that, and the remainder becomes zero now. That means every other digits afterwards become 0 0 0 0 0 0. This is one way of doing it. Other ways, again, you can do this way, that the way I did, right? You can do this way also. You can divide by 2 and then do this way. Okay, it's up to you. But one thing we remember is, we need to remember here in this case, in case of subnet mask, is it has to be this way only, that we have to ensure that it starts from left in form of 1. It will never happen that, you know, just any calculation which can make to 20 to 24. No, we have to start from left, and we have to ensure that the right, the moment the zero starts, it will never be 1 afterwards. So that we need to keep remembering. Okay, so that means this 1 1 1, right, becomes the, so now this is the 1. Okay, now here read this definition. And the least significant bit is the last bit which is on in the mask. It starts from this side. The first, the second, and the third one is this. What is the least significant bit? Can anybody tell me in this case? Are you putting in the chat, any of you? And if you understood this yet? Okay, Satya, your answer is right. But let other come back. Probably I should not have said your answer is right. So you told the value of it. So anybody want to put this in the chat, or want to unmute yourself and want to talk? Okay, so this is the least significant bit. And what is the value? 32. Because if you read the definition, the least significant bit is the last bit which is on in the mask or subnet mask, right? So this is full, this is full, this is not the end of it, this is not the end of it. The end is this one. This is the last significant bit, because after this, every other value is 0. This is the last significant bit. And what is the value? Because of this reference, this value becomes 32, right? So the correct answer is the block size of this particular subnet mask is 32. Okay. Any questions? Anybody has questions in this? No? Yes? Okay. Fine. I hope you understand. So if you have not understand, I have one more example for you with this one, the bottom one. It is in the form of cider. Okay. Block size continue. Block size calculation of subnet mask this /14. Now /14, how I have to represent? It is more simpler, right? That means there, because I mentioned that it will always be contiguous one unless the 0 starts, right? So that means it will be 14 contiguous 14 contiguous 1, right? So there are 8 ones here, and we have to make 6 ones here. That means 1 1 1 and 1 1 1. That's why it count, if you see 8 and 6. So that's the meaning of /14. Very simple, right? You see this represented day in day out in networking nowadays, right? So that's why it's important for you to understand what the meaning of /14 or /24 or /30 or /32 and so on and so forth, right? So what is the least significant bit in this case? Anybody can guess? What is it this bit? Is it this bit? Is it this bit? Which bit is that? You can put in the chat if you are looking for, you can tell the value probably. You can't pinpoint exactly where, but you can tell the value of least significant bit if you understand it. 4. 4 is the value. 4 is, I mean, least significant bit, of course, it's a value of that. You're right, Aman. So this is the, so let me make it bigger. So this is the least significant bit. The value of this is 4, and you multiply 1 with 4. It will be 4, right? The value of this will be 4. Similarly, here I did not say you have to multiply. You have to multiply because it's a 1, so it will be the same value as the positional value of that particular position, right? So similarly here it's this position, and the value of this position is 4, so I have to multiply 1 with 4. That becomes 4. That's why the block size of this subnet mask is 4. I hope most of you understand. If you do not understand, I will advise you to, once you get the recording of this session, you go back and try to understand. If you still do not get it, you can ping me separately on LinkedIn. I pinged my profile. If you do not know, then you can talk to Abby. She can share my LinkedIn profile. I can explain to you again if you want. Okay. So
Sorry, one question. So, are we referring to the same subnet mask that we saw in the previous slide, that 255.255? I mean, this 8 ones and then the second block of one, that is for which subnet mask? I'm trying to understand.
which, sorry,
In
so
this,
I have taken two examples. One is this one, and one is this one. Both are just same IP address, different subnet mask and different representation. This representation of subnet mask is decimal. This
yeah.
is cider. Okay. So this, did you, when I was explaining
Oh.
you, I was explaining this one, you were here?
Yes, yes, yeah. This I got it. Yeah.
Yeah, so same thing, like this IP address with a different subnet mask, I explained in the next slide, which is this one,
Okay.
/14. So
Uh,
subnet mask is /14.
okay.
Okay, let me, okay. This is good. You ask maybe somebody else, if they have not understood, it will be good for them also. This is a cider representation of subnet mask. This was 255, 255, 224 was the decimal representation of subnet mask. Okay, that's the only difference. Okay, this is a cider representation. I'm not saying this is the same value, it's a different value, but the representation is, this is called cider, classless inter domain routing. Okay, So this is the representative. What is the meaning of this? Is this that you will be, as I mentioned earlier, the subnet mask will always have contiguous ones, which means on. The moment it goes off, it goes completely off. There is no possibility that you will get one after the zero starts. No, it will always be zero afterwards. It has to start from left, one, 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 and it will go. So that count of this slash 14 means there will be 14 ones contiguously. So 8 bits will be here. We know that there will be octet. There will be 8 bits in every number, right? So there will be 8 here. And then there is the possibility of 8 here, but we have only 6 because 8 plus 6, 14. So only 6 will be here. 1, 1, 1, 1, 1, 1. So 6 are done. Now, question here is what is the least significant bit? The definition of least significant bit is the last number which is on. From left, if you go right, the last number which is on is the least significant bit. That's how this number, this one becomes the least significant bit. And what is the positional value of this position is 4. So we multiply 4 with 1 and we get 4. So 4 is the block size of this subnet mask. Understood? Anybody is still
Yeah, got it. And
having
so
questions?
the possibility of total, I mean, the maximum value will be 34 here, slash 34.
Which, sorry, I'm not getting. Oh,
I mean, so
one.
you have, like here we have represented, since this is 14, we have 14
Mm-hmm,
ones. So I'm
mm-hmm.
just checking, like, what if, how it will be a
Oh,
14.
yeah. If you
Yeah.
understood, are you, no, you complete your question. Let me see if I'm understanding it correctly. Yeah,
Yeah,
complete
yeah.
your
So
question.
what I'm
Sorry.
asking is, so if it is 14, okay, if it is, for example, if it is 16, these two blocks completely will be one.
Exactly, you're right. And the
And
representation will be in
uh,
this case, it will be this will become 255 and this will be the two digits will not be missing. So you can add 128, 64, 32, 16, 8, and 4. That way you can represent. So probably you can say 255 minus 3, this will be 222. So sorry, 252. So this will become the decimal representation of slash 14 will be 255.252.0.0 is a subnet mask in a decimal format.
okay, okay, got
I
it.
think just spend some time once it's available. You are the first person to see the recording, right? So just check the recording whenever you get time. You will understand. Okay.
Sure, sure.
Hope all of you are enjoying this. Okay, we are moving toward the last part of the session. So this is very important. Now you are also thinking that why I need to understand these subnetting, I mean, subnet mask and then a block size. This is the slide which will help you to understand how block size helps in subnetting. What is the subnetting? Subnetting means you are chopping a big network into smaller network. Let's assume you are having, I mean, you all know that there are that 8 bits in every 4 octet and there are overall 32, right? So let's say I'm having a network which subnet mask is 255.0.0.0. That means I'm only covering 255 for network. I'm allowing the remaining 8 into 3, 24 bits for hosting. That means on the single network, if you have not chopped your network and divided into multiple subnetwork, right? You're having those many, I mean, thousands. You can calculate how many devices you'll get, right? I mean, again, that is something probably I can cover in the next session when I'm going to talk about VPC. But probably today's session will give you a bit of understanding of the subnetting. So coming back, why subnetting is important, I was talking. So you'll be having thousands of availability in a single network. If you do not subnet, if you do not chop that network and make it smaller. Why it is important? Practically and from security perspective also. Practically, uh, every team, right? Every team in office, right? I mean, there are very less team which are probably you can say 1,000, I'm talking about the team which are working on a specific thing. I'm not talking about, because there are teams who, of course, they're in bigger numbers, but generally a department has maybe 15, 50, 200, right? Those kind of numbers you see, right? So you will probably have some buffer and then create that particular network which dedicated for that particular department for a specific work, right? Or even an office and all that. So you're not going to create that of I have a network which allows 50,000 devices on single network, right? From security perspective also it is, because if from security perspective, if a hacker is able to get into your network, right? I mean, the whole 50,000 devices will be impacted, or there's a possibility of impaction. But if you have chopped a network and make it, I mean, there is something called network segmentation. Sorry, I mean, so basically, again, those topics are from security perspective, but that's practically how they do. So the point I'm trying to highlight here is the network has to be uh, converted, or sorry, have to be divided into multiple subnets, private subnets, public subnets, something we're going to talk about in VPC session. So that's the importance of subnetting. Now, coming back, how block size helps in doing that, okay? Or at least from understanding perspective, you'll come to know now. So now, here I have a IP address called 10.0.0.11/29. So this is the network. This is not the IP address of a device. So this is the network I have been given, okay? So sorry, I'm my bad. So this is the network I have, 10.0.0.0/29. The subnet mask. A customer IP is 10.0.0/11/29, belongs to which network and subnetwork. Now this question is not relevant right now. This question I will ask when I'm done with my subnetting, okay? Then this question will be for you. Now, find out the block size of /29, the subnet mask, right? So here, I think I had highlighted, but somehow it has not come properly. Here, I'm directly giving you the answer. I think it has come, but yeah, somehow this top part is not. So this is the block. So if you see this number, right, /29, that means that contiguous 29 ones, 8, 8, 8. 8 into 3, 24. Now you are left with 5. So 1, 1, 1, 1, 1. So this is the last 5, right? So last 5, the fifth, this is the least significant bit, LSB. Okay. What is the value of this as per the position of this number? What is the value of this position? It's 8. 8 into 1, 8. That's a block size 8. Okay. Now if I have to divide this network, I can take the help of block size. Pay attention here. So if I have to divide, you can see how it can be. I mean, how will I know that how many is a possibility? How many network I can create? This also there is also a term called custom subnetting and all that, variables length subnets and all that, right? So everything you will see here. So the subnet one will be 10.0.0.0/29 is the actual network, right? Now plus block size, just do the block plus block size, means 10.0.0, 10.0.0. From here, there's a 0, you add 8 into this. That becomes 10.0.0.0 slash, sorry, .8. You understood? So I added 8 into this 0, because I know the block size is 8/29. The next I can do subnet 2, 8 plus 8, 16, 16 plus 8, 24. Can I add one more 8? No, because it will go beyond 29. So what are the network, what are the devices in this? So devices will be, it will start from 9 and it will go to 15, 9, 10, 11, 12, 13, 14. So 10.0.0. So it will start from here basically. So it will go to, so if I talk about this one basically, then it will start from 8 to 15, then this will be 0 to 7, and then 7, sorry, 8 to 16 in this one, and then 17 to 23 in this one. Now what I'm saying is, there are a few more concept, right? So basically, okay, coming back to this question, right? So this question 10.0.0.11/29 belongs to which network? Can somebody
Subnet
answer it?
2. Subnet 2.
Subnet 2, because it is between 9 and 15. So this comes into this. So what you have seen is we have chopped this network into three subnets. Okay. Uh, Again, there are concepts like there are two bits, or yeah, there are two bits or two positions which are reserved. One is for broadcasting, and one is for I think I forgot the purpose. So there are two again, those these topics, something I'll cover probably in more detail in the BPC session, and probably I can spend 20 minutes or 15-20 minutes overall when I explain the cider in the context of AWS and all that. But I hope that after this session, you understand the subnet mask, you understand the significance of subnet mask, you understand the block size, and you understand what is the significance and how it helps in subnetting. So this is not the only, or this is not the whatever topics I have covered. I do not mean to say that this covers everything in subnetting. Probably it covers 70-75% or even 80% of subnetting. So there are 15 or maybe 25% or 20% left out, which if time permits in the next session I'll try to cover. But this should be giving you sufficient understanding so that once we are creating subnets and the other artifacts in VPC session, you should be able to understand it. Okay. So with that, I'm done. If you still have any questions, please ask. Yes, broadcasting and is it gateway? I forgot the. Yeah, there's some other term, I think. Yeah, one is for broadcasting, one bit, and one bit is for something else. Yeah. Let me stop sharing. I'm still sharing. I think I've stopped sharing, right?
It is sharing only, Pawan. Yeah, that's fine. So if you
Okay.
have any questions, like you can unmute and ask. Otherwise, we are having two questions on the chat, Pawan. So I will get that. So one person have asked someone, can you give us some of the other differences between the TCP and UDP based on real time, real world examples?
Yeah, I think that's why I wanted to, did not want to go to that direction, because otherwise I could not have been covered this. Unfortunately, I am not in great health today. So you might, those of you who have attended the previous sessions, I think I'm not very well today. But yeah, definitely for UDP, yeah, I will try to cover, not in the next session, because the next session of VPC itself is a huge topic, but UDP, if you want, probably I can. I'm not creating a video on regular interval, so I'll see what I can do. If possible, we can take a specific session where we can cover a few more topics. Like for example, if you have some of you have other feedback, like a this is a specific topic from networking and all that, we can club all those topics together, and we'll try to deliver one more session probably. But at the moment, probably VPC I'll try to cover, but I'll keep in mind when I can do the UDP along with some other concepts. Definitely, I can try to do that.
And one more question is on can we use all IP addresses in a subnet or some are reserved? I think you already answered that, I guess. One is for broadcasting and one more is for.
Yeah, I need to check that. I
Uh,
somehow I'm still
I
not able to
checked that
recall.
it
But
is
again,
network, I guess, networking. So,
yes, it's a network. Yeah, it's the right answer. So it's one is for network. The router needs that for network. Otherwise, what will happen if you're just taking that address also? That router will not. I mean, your network will behave haphazardly, because it needs that for from routing network purpose to understand where the packet has to be sent and other things. So yeah, I think one of them is for network and one of them is for broadcasting. Yeah. But again, like these things, I did not plan to cover, but because there are more details around it, so I do not want to cover at superficial level. But yeah, if you want to cover, probably I'll include when I'm going to cover the UDP session. I'll provide more detail about it.
Yeah, sure, Pawan. Actually, it was a great session, Pawan. It is like a brushing up the basics from the OSA layers, and then you have covered the subnets and as well as the IP addresses, right? So both are actually very good.
Yeah, I mean, I did not feel that it was. I think I was at my best because of my health, unfortunately. But yeah, that's fine. I did not want to postpone it once more. It's already been postponed once. So yeah,
Yeah, yeah, yeah.
thank you.
I can understand.
So
So, but thanks for showing up today.
yeah.
Yeah.
So thank you. And again, as I mentioned, those of you are not connected on with me on LinkedIn. So please, I think I pinged in the chat in the beginning of the session. You can connect with me over LinkedIn. Okay.
Because we are
So
having a
if you
yeah, yeah, go ahead, Pawan.
if you allow me, then yeah, thank you everyone for the feedback. Probably, if you really like the session, not just this session, even previous sessions, probably you can post on LinkedIn what you liked about the sessions and all that. So, and if any other feedback, of course, we are looking forward to improve upon every single time. This time, probably, as I mentioned again and again, that I am not giving my best today, but yeah, I just wanted to deliver still, regardless of my situation. So, yeah, thank you.
But it's a great session, Pawan. That you don't need to feel like you didn't give your best, but that's very it was insightful for me. Yeah.
Yeah,
And
thank you.
if you want any specific session, right? So you can put it on the chat or otherwise ping me on LinkedIn so we can arrange a session as well on that topic. Yeah.
Yeah.
So
Okay, so if you allow me, Abby, Rasika, and other organizers, so can I drop off?
yeah,
You
sure,
can continue
Pawan.
with the quiz. Yeah,
Yeah, yeah, sure, Pawan. Yeah, thank you so much. Yeah, thank you so
yeah.
much
Thank
for
you.
the session.
Thanks. Bye.
Yeah,
Okay,
sure,
Aman.
Aman.
Yeah, made a note of it. Yeah. Thank you.
Thank you, Pawan.
Thanks. Bye bye.
And guys, you can enter the like quiz session. So you can open Slido and put this code. Otherwise, you can scan it, and then it will be. If you scan the QR code, it will be redirecting to that. I saw. So I think three of them were joined. Like almost 12 to 13 members are there. Can you join? And also, I have pinned the coupon code for the AWS Community Day. So it will save you, I think, 150 to 200 on the early bird ticket. So the day is of three different tracks and workshop also planned, and then you can meet a lot of AWS professionals and over there, and you can connect and then network as well. So the topic title will be published this week, Dinesh. CFP also in the process, so we will publish that this week. So that keynote and technical keynotes will be from the AWS, and then post that like we will have a track of GenAI and data security and serverless as well. This way it will. And one more hands-on workshop will be there at afternoon. That is also from the AWS team only. Okay, can we start the quiz or anyone else to join over there? Okay, I'm going to start the quiz, but it's already late like for you, like it's been 2 hours now. So what's the main role of server in the client server model? Yeah, the correct answer is to provide services. And how many layers are there in the OSI model? So what's the answer? Yeah, probably everyone answered it correct. Which of the following is a layer in the TCP/IP model? Okay, 83 answered it correct. The coupons which I shared in the chat, right, it will be applicable for this session alone. Like it will be on for like next to 2 to 3 hours. Then it will be coming to the you can't insert code. Screen. What does the block size represent in the subnetting?